This video illustrates the basic concept of positional tolerance as it relates to locating cylindrical features of size. The objectives covered in this video include introducing positional tolerances, defining the term true position, demonstrating how conventional tolerancing results in establishment of a square tolerance zone, and discussing the basic use of positional tolerance. Please pause and replay sections of this video as needed to ensure you are understanding the content. One term to become familiar with right away is true position. True position is the theoretically exact location of a feature. In this example, we are locating the theoretically exact location of a hole's center. Therefore, you should note that this requires the use of basic dimensions. Remember, basic dimensions specify theoretically perfect values that are not affected by general print tolerances. Similar to what we have previously discussed with angularity tolerances, basic dimensions must be used because the tolerance zone is defined by the geometric tolerance found in the feature control frame, not the dimension tolerances. Let's begin by taking a look at the shortcomings of conventional tolerancing when locating the center of a round feature of size. Here we have a drawing of a simple block with a hole in the center of the object located using two dimensions. Because each dimension includes a plus-minus tolerance, we understand that the actual location of the center may vary within the stated range. The same is true for the other dimension. As you can see, the cumulative effect of the locational tolerances results in a square tolerance zone. The actual center of this feature of size can exist anywhere in this zone. Do you see anything wrong with this method? If we plot a distance from the true center location to the side of the tolerance zone, and a distance from the same starting point to the corner of our tolerance zone, it becomes clear that the distances are not equal. So, which distance is correct? During the inspection process, this conflict can result in good parts being rejected and bad parts being accepted after the part has been manufactured. A more reliable application would be to establish a tolerance zone that mirrors the actual geometry of the feature of size. In other words, a round tolerance zone defined by a diameter value would be a more reliable and accurate means of controlling the center location of a hole than a square tolerance zone that results from the use of conventional tolerancing methods. This is where the positional tolerance symbol is applied. We can now provide a more geometrically accurate tolerance zone to ensure parts are inspected in a more precise way. Note that when the positional tolerance is used, we no longer use size tolerances on the location dimensions. These are now defined using basic dimensions.